All right, so like I said, we're starting exponential growth today. Okay, so we've been talking about one type of growth pattern all year. And the type of growth that we've been talking about so far this year is linear growth or constant growth. Okay, so we're going to look at some comparisons between linear growth and exponential growth, what makes them different, how they're sort of similar.
Parabola.
Um, so we're looking at a pattern here. So we've got blocks and they're building bigger and bigger and bigger as we go across, okay? So what we have here is we're gonna have our section numbers. We're gonna fill those in as our X values or our inputs because these are functions, okay? We're gonna take our section number as our inputs, so 0 through 4. And the number of bricks is gonna be the output. So section 0 has 1 brick, section 1 has 3, section 2 has 5, section 3 has 7, and section 4 has 9, okay? And how we got those numbers is we're just counting the blocks for each section. So 1, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, etc. Okay? Hopefully, looking at this immediately, we see a pattern. As we go up by 1, we're going up by 2 in the y direction, and that's consistent all the way across. Every single time, plus 2, plus 2, plus 2, and plus 1 across the top. This is a type of growth that we should be pretty comfortable with at this time. This is linear growth. We know it's linear because it's going up by the same amount repeatedly, okay? 2 over 1 would be our slope. If we were to graph this data, that would become our slope. When we're talking about recursive rules, we haven't talked about these since the beginning of the year, but if you remember, a recursive rule is just a fancy word for a sentence. Say the pattern in words. So our pattern here would be starting at 1, add 2 repeatedly. Okay? Everybody pretty comfortable with that? We've been talking about lines all year, so I'm hoping that we're pretty comfortable.
Yeah, it looks pretty easy.
Excellent. So now we're going to switch it up. So we're looking at pattern B now, and there's a lot more blocks going on with pattern B. In fact, it's kind of growing a little bit more quickly versus this one that kind of took its time growing, okay? So this function, our input again is our section numbers, which is 1 through 4. And our outputs are number of bricks. So in section 0, it's kind of hard to see. I'll see if I can like zoom in a little bit on it, okay? But we've got 1, 2, 3 in section 0. In section 1, we have 1, 2, 3, 4, 5, 6. So we added 3. In section 2, we have 6 plus 1, 2, 3, 4, 5, 6. So that makes it 12. So just those 3, hopefully we're able to see some pattern, maybe a different type of pattern, but a pattern emerging. Section 3, I've got 12, and then I've got 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So any guesses on what 4 is going to be? Exactly, 48. So looking at our pattern here, again, we're going up by 1 every time in the top, which is good. That makes it easier to compare. Okay. However, in the bottom, we're not going up linearly. We're going up by a different amount each time. We're going up by 3, then 6, then 12, then 24. Okay. So this pattern, we wouldn't say we're adding every time. We would say we're what?
Multiplying.
Exactly. We're multiplying. And in this case, we're multiplying by 2. We're doubling, right? Doubling would be the word we use in everyday life every single time that we talk about multiplying by 2. Okay. So our recursive rule for this guy, and remember that's just a sentence, would be starting at 3, multiply by 2 repeatedly. And in theory, this pattern can go on forever. If we had a section 5, it would be 96 because that would be 48 times 2. And we can keep going and get as many sections as we want. Okay, and this is just like when we were talking about arithmetic sequences at the beginning of the year. We want to come up with some way to find an explicit rule or an equation so that I can solve for any section in this pattern. Okay, this is really easy to do times 2 times 2 times 2 over and over again recursively. But if I want to know the 47th section, that's going to take a really long time and the number is going to be really big. So eventually by the end of the week, we're going to talk about how we come up with the explicit rules for these different types of patterns, the ones that aren't linear, the ones that are multiplying repeatedly, not adding or subtracting, okay? We're gonna do 2 more of these guys together, and these 4 patterns are gonna be on what's gonna be your practice for tonight, Okay, so if you have any questions before we leave, make sure you ask them. Okay. Exactly. So somebody said in the chat, exponential growth is like linear, but it's multiplying. That's 100% true. So instead of adding repeatedly, we're multiplying repeatedly. Okay. So looking at C, looking at this picture, I can tell this is going to be linear because the gap each time is the same size, which means we're adding the same number over and over again. So again, we've got our section numbers as our inputs. We got 0 to 4. Starting at 1 in section 0. Next one, we've got 5. Then we've got 9. So it looks like we're adding 4 repeatedly. So we're going to have 13 and 17. Okay, so again, we're adding 4 repeatedly all the way across. And across the top, we are going up by 1. It's important to note because if those numbers are different, we've got to adjust what we're adding. Okay. So right here, our recursive rule for this pattern C is going to be our sentence. So starting at 1, because 1 is in section 0, we're going to add 4 repeatedly. Okay, so just an arithmetic sequence. This right here is what we started our year doing, our arithmetic sequences. Okay, we didn't cover what type of sequence this guy is called. Okay, this is called a geometric sequence. Yes, exponential loss is a thing as well. We're going to start with growth for the most part, and then towards the end of this unit, we'll talk about exponential decay is what it's called. Okay, so pattern D, we've got our section numbers again as our inputs, and our outputs as our number. Now looking at this picture, it gets really big really fast. That's the thing about exponentials, okay? That's why when we're talking about like a disease or like a zombie apocalypse, that's why exponentials is what drives that. It's because it gets really big really quickly. Adding 3 repeatedly is not the same as tripling. Tripling makes things get bigger by a factor of 3 over and over and over again. Okay, so section 0, we're starting out with 1. Section 1, we've got 3. So knowing that I see that it's probably going to be exponential, looking at the first 2 terms, I already have an idea of what my recursive rule is going to be. Okay, so here I've got 9. And I'm going to quick check the chat, see if anybody knows what our pattern is going to be. Anybody know what our pattern is going to be here? What our rule is based on our first 3? Exactly. Exactly. Really close. 3. We're tripling here, okay? So 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Okay. So I didn't even have to count here. Okay. I could have counted all 81 of these rectangles, but that would take me a really long time, and I don't want to do that. So we see we're going up by times 3 all the way across. Okay. And it's important to note we're going up by 1. Okay. If we were going up by 2, we'd have to multiply by 3 2 times. But since we're going up by 1, we're good. My recursive rule, starting at 1, because that's what our 0 section started at, we are multiplying by 3 repeatedly. Okay, so they're very similar. We're doing something repeatedly, just with linear, we're adding or subtracting repeatedly. With exponential, we're multiplying repeatedly. Okay, geez, guys. All right, I'm gonna stop recording.